Okay, so this is a problem about lie detectors and their use in the criminal justice system. And the most favorable estimate is that 90% of the time when a person is lying, it detects it. 95% of the time when a person is telling the truth, it shows it. So for the police department's model, they assume that about 15% of the people that they question will lie at least once. And remember, positive result means the detector says you're lying. A negative result means the detector says you're telling the truth. Okay? So it asks you to make a tree or a table. We're going to make a tree. Okay? We're going to make a tree diagram right there. And so lying has a possibility of that in the population according to the police model and that. So we want to know how well this is going to work. So 90% of the time when a person is lying, it tests positive. So we get 0.9 there and 0.1 there. And then 95% of the time it identifies truth, which in this case is a negative result from the lie detector. It means it doesn't detect a lie, and 5% works like that. So at the tips out here, 0.15 times 0.9 is 0.135. Okay, this is 0.015. This is going to be 0.0425, and this is going to be 0.8075. Okay, so those are the things. That's part A. That's the tree. So part B, what is the likelihood that someone who tests positive is telling the truth? So here's what we have to, T is for truth, test positive. So that's the probability of T intersect positive over the probability of positive. Okay? So positive occurs here and here. So telling the truth but testing positive. So the denominator is 0.135 plus 0.0425, because that's all the places that it would have tested positive. And then truth and positive is going to be 0.0425. And this turns out to be about 0.239. So just under 24% of the time, the person will be telling the truth, even though they've tested positive. So that's part B. It's not really good. That's about a quarter. So let's see what happens for C. What is the likelihood that someone who tests negative is lying? Okay, so just for our little symbolism, so they test negative means they're lying. Okay, the negative means that it says they're telling the truth. Okay, and so our probability is lying intersected with negative over the probability of negative. So this computation, I'll put it right down here, is going to be negative is here and there. So if we put 0.8075 plus 0.015, okay, if we put that there, and then it says test negative, but they're actually lying, so we go up the lying branch and find negative, so that's 0.015, and if we do that computation out, we get 0.018. So I hope that's helpful. Remember to try to figure out how your sample space is restricted, and then what portion in that restriction meets the condition for the other one. Thank you. Bye.